This is Chapter 2, Lecture number 1, and we're going to start looking at data that we collect. We make measurements every day. Although in the United States we use the English system, the majority of the world uses the metric system. In fact, there are only 3 countries that do not use the metric system. Us, Liberia, which is in Africa, and Burma, which is in Southeast Asia. So the metric system was updated in 1960 to what we call the SI units. We don't have to know that name, we just have to be familiar with the units. We've probably seen some of them before. Length is going to be measured in meters. Mass is going to be measured in kilograms, and temperature will be measured in Kelvin. To extend the base unit, we use prefixes. So again, you should be familiar with the kilo, which means 1,000. So a kilogram is 1,000 grams. The main ones we use are the kilo, the centi, and the milli, although you will be responsible for more. Temperature is a quantitative measurement of the average kinetic energy of the particles that make up an object. At the atomic level, the more kinetic energy, the faster the particles vibrate or move, and the higher the temperature will be. So as the temperature of an object increases, its average kinetic energy increases. We don't use the Fahrenheit scale in this course. We do use the Celsius scale, which is used throughout much of the world. The freezing point of water is equal to 0 degrees Celsius. The boiling point of water is equal to 100 degrees Celsius. Kelvin is another temperature scale. 0 Kelvin is the temperature where all particles have their lowest possible energy. At 0 Kelvin, the average kinetic energy is 0. The Kelvin scale has the formula Kelvin is Celsius plus 273. So on the Kelvin scale, water will freeze at 273 Kelvin. Notice there's no degree sign. And water will boil at 373 Kelvin. At this point, pause the video and work out these two conversions. So minus 39 plus 273 is 234 Kelvin. Notice one of the positives is that on the Kelvin scale, you will not have a negative value. For the other one, Kelvin is equal to Celsius plus 273. So if we have 266 equals degrees Celsius plus 273, we subtract 273 from each side, and degrees Celsius is equal to minus 7. Notice that a 10-degree change on the Kelvin scale is equivalent to a 10-degree change on the Celsius scale. We also have what are called derived units. It's a combination of the base units. For volume, we have the liter, which is equal to about a quart. If we have a regularly shaped object, volume is length times width times height. If we have an irregularly shaped object, we use water displacement with a graduated cylinder. Density is a physical property of matter, defined as the amount of mass per unit volume. So density equals mass divided by volume. We can use density to identify an unknown substance. And so here is a typical problem. We have an object with a mass of 7.5 grams. It changes the water level in a graduated cylinder by 5 milliliters. What is the density of the object? We use ESA in this course, so equation, substitution, answer. So density is equal to mass divided by volume. So density is equal to 7.5 grams. The difference between 25.1 and 30.1 is 5.0 milliliters. So the density on a calculator is equal to 1.5 grams per milliliter. That is it for today's lecture.